Alright, so here's number 10 from the homework for this section. I don't know if number 10 is going to be assigned to you, but it's still a good problem. We're being asked about ACT scores. The average ACT scores in a given year have a mean of 21.1, and they are normally distributed, meaning they form a bell curve. That's not a great bell curve, but let's use our imagination. 21.1 will be in the middle, and the standard deviation is 5.3. Okay, standard deviation 5.3. And we have to find a bunch of probabilities. So you randomly pick a high school student. What is the chance that they got less than 16? Okay, so less than 16 would be maybe right here, and that's asking about this red area. Okay, then we want to know between 19 and 24. Okay, so the sketch doesn't have to be perfect, it just has to be a rough sketch. So 19 to 24 would be in this blue area right here. We have to find that. And then finally we're being asked about more than 26. Okay, so you can kind of get a sense from the picture of how these should look. And then any unusual events. So you may or may not remember from earlier we said any z-scores that are less than -2 or any z-scores that are greater than 2, okay, would be considered statistically unusual. Now here's the thing, we don't have z-scores here, we have areas. So how does it work with area? Well, let's recall this rule from way back at the beginning of the year, that was a terrible bell curve, the empirical rule. And the empirical rule said that 68% of the data is within 1 standard deviation. Okay, and then how much was within 2 standard deviations? It was 95% of the data. Okay, 95% was plus or minus 2 sigmas, meaning 2 standard deviations. So if it's unusual, that means that you're going to be either over here, okay, or you're going to be over here. Well, how much is left outside of 95%? And the answer is 5%. So if you have a less than 5% chance, okay, if you're in this region or in this region, that's where we start to draw the line in terms of usual and unusual. Okay, so that's kind of what we have to keep in mind as we're doing this. Okay, and obviously 3 standard deviations would be very unusual. So let's calculate each of these. Okay, so for the first one, this is less than 16. Okay, less than 16, we're going to put normal CDF. And what is the lower boundary for less than 16? That's right here. Lower boundary is -infinity, so we'll use -10,000. Upper bound is 16. The average is 21.1. And the deviation is 5.3. So that's what we have to put in for the first one. Okay. Next one, NCDF is just my abbreviation for normal CDF. Okay, we're between 19 and 24, so those are going to be our boundaries, and these numbers will still be the same. So that's what we have to put in for part B. And then finally for part C, it's going to be NCDF greater than 26. So our lower boundary is 26. Our upper will be positive 10,000. And we still have 21.1 and 5.3. So if you put those numbers in, the less than 16 chance of that happening should have been, let's see if I can get this to move here. Oops, those should be the answers right there. So 0.1685, 16% chance. This one is 36%, this is 17. But remember, 95%, that leaves over 5% in each one. So there's not a less than 5% chance of any of those things happening, which means none of them are unusual. Obviously, the 16% one is a little bit more unlikely than the 36% one, but still not considered statistically unusual.